Good morning, everyone. I am Vijay Krishna, Assistant Professor in the Department of Mechanical Engineering. Today, we are discussing about the outcome-based education of a subject called Engineering Tribology. Okay, we will see now. This Engineering Tribology course code is AMEC 024 and it is offered for the BTech 5th semester students of Mechanical Engineers, and it is under the regulation of UG 20. Here, the credits for this subject is 3 credits and the lecture hours are 3. Now, we will go and we will see in-depthly about this OBE of this engineering tribology subject. Now, see here the prerequisites. The prerequisites for this engineering tribology subject is uh, is nothing but chemistry, engineering mechanics, and the material engineering. These subjects are required for understanding the engineering tribology subject, because this subject involves study of wear, friction, and the lubrication. Because of that reason, in the second semester we will be studying chemistry, that will be useful, and then same second semester mechanics also there. In the third semester, material engineering. The subject of these subjects are required for understanding the basics of the engineering tribology. Now we will see the course overview of this subject. Engineering tribology explores the latest innovations in the study of friction, wear, lubrication, and to solve the practical manufacturing challenges in order to take a deep divide into the tribology trends and strategy, including those related to the surface engineering. Generally, engineering tribology studies about what are the latest innovations that are undergoing in the friction, wear, and the lubrication to solve the whatever the challenges are there in the manufacturing industry. Okay, in order to reduce the surface coating problems which are facing in the current industry. Second point, tribology is the art of applying the operational analysis to problems of great significance, namely reliability, maintenance, and the wear of technical equipment, and ranging from spacecraft to the household applications. Okay, here tribology is nothing but a subject or a concept will be applied to the operating conditions of an objects or the machine parts, so that its maintenance cost and its reliability will be improved if we apply the concepts of tribology to any manufacturing process. So, next point, the essence of tribology at a design stage yield substance economical benefits. By ignoring the tribological principles, if we do the design process, then there are chances of maintenance problems and the reliability problems, so that when this cost will incur, then such cases the cost of the product increase. So if in the starting of the stage only, if we are considered the what we will call tribological principle, then we can able to reduce the maintenance cost, which will lead to the economical benefits in the design of the cost. Next, the different lubrication standards and its application in the industry are addressed here. Here, in tribology, we will be studying more about the tribal lubricants and its role, and what are the standards to be followed while using the lubricants, and what are the applications of one particular lubricant at the application level. Okay, this is a brief introduction or the course overview of engineering tribology. In simple, engineering tribology deals with the friction, wear, and the lubrication. It is a concept of applying the all these 3 parameters into the manufacturing industry, so that it may give the economical benefits to the component manufacturing during the manufacturing process. The marks distribution for this subject will be having in the form of you can see, okay, engineering tribology SE examination you will be having 70 marks, and CAE examination you will be evaluated for 30 marks. Totally The subject is evaluated for 100 marks. Okay. Then the content delivery for instructional methods, the content delivery and the instruction method for this particular subject, mostly we will involve in PowerPoint presentation, sometimes chalk and talk, and sometimes we will be giving the assignments. Remaining will not be using MOOCs, so open-ended experiments, seminars, mini project, and the videos and all those will be considered. Okay. Open-ended experiments also will be given to you, and we will be addressing to go for the MOOC courses also. Okay, the content delivery for this particular subject will be having the PowerPoint presentation, chalk and talk or whiteboard we will call, and the assignments will be given, that is nothing but AAT, and the MOOC concepts also will be introduced. Evaluation methodology for this particular subject under UG20 regulation is the course is evaluated for 100 marks with the 30 marks continuous internal assessment CIA and that 70 marks for the semester end examination CIE. CIA is conducted for total of 30 marks with the 20 marks for continuous internal examination CIE and 10 marks for an alternative assessment tool AAT. Semester end examination we will call as SEE. SEE conducted for the 70 marks of 3 hours duration. The syllabus for theory course is divided into the 5 modules, and in the each module carries equal weightage in the terms of marks distribution. The question paper pattern is as follows. 2 full questions with either or choice will be drawn from each module. Each question carries 14 marks. There will be maximum of 2 subdivisions in this question. The expected percentage of cognizant level of question is broadly based on the criteria given in the table below. The percentage of cognizant level and the Bloom's taxonomy level we will be discussing here. 30% of it will be the remember and 40% of it will be the understand and 30% will be in apply, and the 0% will be then analyze concepts, will be maintained at the cognizant levels. Okay. CA is conducted for the total of 30 marks and the 20 marks for internal continuous examination CIE and the 10 marks for AAT assessment tool. Okay. CIE continuous internal examination 1 midterm 10 marks and the continuous internal examination 2 midterm 2 for 10 marks and AAT 1 for 5 marks and AAT 2 for 5 marks. Total CIE will be 30 marks and SE semester end examination is evaluated for 70 marks. Total the subject is evaluated for 100 marks including the 30 marks for CIE and the 70 marks for SE examination. Continuous internal examination CIE 1, CIE 2 CIE exams shall be conducted at the end of the 8th and the 16th week of the semester respectively for 10 marks at each of 2 hours duration consisting of 5 descriptive type questions out of which 4 questions has to be answered. AAT, alternate assessment tool. This tool enable the faculty to design own assessment patterns during the CIE. The AAT convert the classroom into effective learning center. The AAT may include tutorial hours, classes, seminars, and assignments, term paper, open-ended experiments, and the METE and the MOOCs. Okay, the AAT chosen for the course is given in the table. Concept video, tech talk, complex problem solving. Concept video will take 40%. And the tech talk also will take 40% and the complex solving problem also take 20%. Total will be evaluated for 100%. The course objectives of the subject engineering tribology are from this course the students able to learn first one is to provide the knowledge and importance of tribology in the design, friction, wear and the lubrication aspects of machine components. This subject provides the knowledge and importance of tribology in where lubrication and friction aspects of the machine components. In simple, tribology plays a major role in the designing of machine components, which involves friction, wear, lubrication. Okay. Secondly, it tribology helps to select the proper grade lubricant for application, specific application. With the help of the knowledge of engineering tribology, the students are able to select the proper grade of lubrication for specific application. For example, liquid lubricants are used between the surfaces. In some cases, you will be having the semi-liquid or semi-solid lubricants such as grease, which are used in one particular application. With the help of knowledge of tribology application, the students will be able to select the proper grade of lubricant for specific application. Next, course objectives is the student will be able to understand the principles of lubrication, lubrication regimes, and the theory of hydrodynamic and advanced lubrication techniques. With the help of engineering tribology knowledge, the student able to understand what are the principles of lubrication and what are the regimes of lubrication. Regimes of the lubrication is nothing but thin film lubrication, thick film lubrication, and the oil lubrication, oil film lubrication. All those types of will be studied, and we will be understand the principles of this one. And he will be studying about the advanced concepts like hydrodynamic lubrication and the advanced lubrication techniques. And the next course objective is the student will able to understand the introduce the concept of surface engineering and its importance in the tribology. The student, with the help of this subject, student will understand the what is surface engineering, what is the role of surface engineering in the industry and the material surfaces, and its importance with the help of tribology. Okay. Next, we will discuss about the course outcomes. Course outcomes. After the successful completion of course, students will be able to understand what are the outcomes will come from the this subject called engineering tribology. First outcome is nothing but student will able to demonstrate the surface topology, physical chemical aspects of solid surfaces, and surface interaction of metallic and non-metallic material to understand the nature of function. With the help of this engineering tribology subject, student will be able to demonstrate what is surface topology. Surface topology is nothing but study of surfaces of the material, or how the surface will affected when it is subjected to environmental conditions or chemical exposures and corrosive exposures. So in the surface topology concept, we will be studying about what are the impact on the surface of a material when it is undergoing to environmental changes condition. Student will also understand what is the physiochemical aspects of solid surfaces. When the material is subjected to chemical exposure, then what are the changes physically and the chemically on the surfaces will be able to study with the help of this subject. And the surface interaction of metallic and non-metallic materials. The students will be able to identify or what are the property changes in the materials and non-metallic materials when they interact with other surface interactions take place. Okay. And it also says what is the nature of the function of surface interaction. Okay. Secondly, the student will be able to make use of the laws of friction, mechanism of friction, friction space, and the surface temperature for tribological application. from the understanding of this engineering tribology subject, the students will able to recall the principles of friction and what are the mechanisms of the friction, and with the help of them he will be able to understand what is friction, how friction plays a major role between the surfaces, and when the friction occur, how the it will change the surface of a surface temperature of a component, will be able to understand from this engineering tribology subject. Okay. Then thirdly, the list, it will, a student will able to list the various types of wears and the wear mechanism techniques. Okay, with the help of engineering tribology knowledge, the student will able to list the various types of wears and the wear mechanism. Wears, there will be abrasive wear, adhesive wear, and the corrosive wear. There are many types of wears will be there, and students will be able to understand what is the principle of this wear, and what is the impact of this wear on the surface, and what are the remedies for solving the effect caused by this particular wears will be using. And we also using what are the wear measurement techniques are available for this particular type of wear with the help of engineering tribology. Okay. Fourthly, your student will be able to identify the lubrication regimes based on nature of contact using lubrication standard as such as ISO, IAE, AGMA, BIS standards and in its applications. The student will be able to identify the lubrication regimes. Lubrication regimes are nothing but what are thin film lubrications and what are thick film lubrication and what are oil film lubrications. Those are nothing but the lubrication regimes. And for every regime will be bonded with some international rules that are followed by the lubrication industries. Lubrication standards are classified as ISO, Indian Standard Organization, SAE, that nothing but Society of Automotive Engineers, and next AGMA is nothing but American Gear Manufacturing Association, and BIS is nothing but Bureau of Indian Standards. These standards are monitor the lubrication standards and the lubrications, whatever the will be used in the industry for what we will call lubrication between two surfaces will be used. With the help of these standards only, most of the lubrications are manufactured, and such manufactured lubricants are used for the application of what we call uh, between the two surfaces. Fifthly, the student will be able to outline the importance of tribology in minimizing the factors influencing corrosion and for protecting the surface coating applications. Here, fifth CO mainly focuses on corrosion, and here the student will be able to understand what is the principle of corrosion and what are the factors it affecting the corrosion, how the corrosion is to be minimized, in what way it is minimized, whether by surface coating or a mixing of alloys in the base material. Like that, he will able to find out what we will call the necessary surface coating method or necessary preventive methods that can be used for reducing the factors influencing the corrosion. Next, sixth one, students will able to select the appropriate material and its alloys based on the composition for anti-frictional applications. Here, the sixth CO is mainly deals with the engineering materials. Here, the students will be able to select the appropriate material based upon the application. In this unit, he will be studying lot of engineering materials like advanced alloy, copper alloys, nickel based alloy. All these alloys will be studied by the student, and he will be able to select the appropriate material for any anti-frictional applications. Okay. Now we will try to discuss first CO, Bloom's taxonomy. Okay, the first CO comes under the demonstrate, so it will be comes under the Bloom's cognizant level of understanding, and the second CO it will use the word of make use, so it will comes into the Bloom's taxon cognizant level of apply, and the third one the list will comes under the cognizant level of remember. Similarly, CO4, which is nothing but identify, it will be coming under the cognizant level of apply, and the outline is under understand level, and the select will comes under the apply level. These 6 COs are framed from based upon the syllabus, and it is mapped to the cognizant levels based on the Bloom's taxonomy levels. This is the course knowledge competition level. You can see in the previous one, previous CO. So how many remembers are there, how many understand levels are there, and how many apply levels are there. You can see in the graph, it is maintained. Graph is what you will call plotted between the Bloom's cognizant levels and the number of counts. X-axis it is Bloom's taxonomy level, and the y-axis is number of counts. So you can see from the graph, remember is counted for 1, and the understand is counted for 2, and the apply is counted for what we'll call third level, because this is the fifth semester subject. We won't have for the analyze or evaluate levels of the Bloom's taxonomy. Now we will see what are the program outcomes of BTech mechanical engineering. Now we will see what is program outcomes. PO1 is nothing but engineering knowledge. Here we apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to solve the complex engineering problems. If PO1 is nothing but engineering knowledge, here we will be using the knowledge of different subjects which we studied to solve the complex engineering problems. We will be applying the knowledge of maths, science, and engineering fundamental which are studied in the earlier semesters. Second program outcome is nothing but problem analysis. Here, problem analysis is nothing but identify, formulate, review research literature, and analyze complex engineering problems, reaching the sustained conclusion using the first principles of mathematics and natural sciences and engineering sciences. Here, with the help of PO, the students will able to identify the formulate and research facilities will be using with the help of the basic knowledge of maths, science, and engineering sciences. With the help of PO2, students will able to identify what the problem and able to formulate the aim of a problem, and with the basic knowledge of mathematics, natural science, and the engineering sciences. PO3, design or development of solutions. Design solutions for complex engineering problems and design system components are processes that meet the specified needs with the appropriate consideration for public health and safety and cultural, social, and environmental conditions. Okay. Here PO3 mainly involves in the design and development of the solutions, or design and development of mechanical systems or mechanical components. Okay, mainly the mechanical students deals with the design, and also sometimes design deals with the development of the machine component. Here with the help of PO3, students will be understanding how to design with the help of the basic subjects and basic knowledge of the natural sciences, and based upon the socio-economic conditions and the environmental conditions. Next, we will try to see PO4, conduct the investigations of complex problems. Use the research-based knowledge and research methods, including design of experiments, analysis and interpretation of data, and the synthesis of information to provide the valid conclusions. Here, with the help of PO4, the students will be able to understand what are the design experiments and what are the research methodologies. Indirectly, they will conduct the investigations on a complex problems or complex methods or the challenges which are used in nowadays in the industries are facing the by the industries. Fifth one, modern tool usage like create, select, apply appropriate techniques, resources, and modern engineering and IT tools, including prediction and modeling to complex engineering activities with understanding of the limitations. PO4 is nothing but usage of modern tool for creating an product or selecting a product and applying the appropriate techniques and the resources with the understanding of limitation. Okay. Next, we will try to see PO6, engineer and the society by applying the reasoning informed by the contextual knowledge to assess the societal health, safety, and legal and cultural issues and the consequent responsibilities relative to the professional engineering practice. Here, PO6 is nothing but the engineer and the society. Here, student will be able to understand what is the role of society and health and safety and the legal copyrights. All those will be understood in order to make the experimental investigations or the further research work. Next, we will try to see PO7, environmental and sustainability. Here, student will able to understand the impact of professional engineering solution in the societal and environmental context and demonstrate the knowledge of and need for sustainable development. Here, student will be able to judge what are the environmental and sustainability aspects of the design of experiments. And PO8 is nothing but ethics, applying the ethical principles and commit to professional ethics and responsibility and the norms of engineering practice. Here, the students will be learning about what we will call ethics and what are the principles of ethics, and that principles are applied in the investigation level or the design level or the design of experiments level by the students. PO9, individual and teamwork. Individual and teamwork. Sometimes some experiments or design experiment has to be done by individual and some experiment has to be done group level. So there is necessary to be group formation and the leading of the group formation also required. Sometimes the student may be member or sometimes student may be leader in diverse team in multidisciplinary settings. Here, with the help of PO9, the students will be able to understand what is his role in a team while undergoing the experiments. Okay. Next, PO10 is nothing but the communications effectively on complex engineering activities with the engineering community and the society at the large, such as being able to comprehend and write effective reports and the design documentation, make effective presentations and give the receive clear instructions. PO10 is nothing but communication. Here students will able to understand how to communicate effectively or nothing but how to pronounce his idea to other people. Then only with the proper communication skills only students able to deliver his idea in the form of paper or in the form of the drawing or in the form of writing, so that when he kept in this form, then he able to understand or explain the students very thoroughly. Next, PO11 is nothing but project management and the finance. Here, he'll be demonstrate the knowledge and understand of engineering and management principle and apply these to one own work as a member and the leader in a team to manage a project and the disciplinary environments. Here, the student will be able to understand how to manage the team and how to manage the project and what are the financial situations, and what are the finance to be gathered from other sources, and what are the funds to be utilized at what time of time, at what process we have to use. We should be Student will be able to understand from this one. PO12 is nothing but lifelong learning, recognizing the need for having preparation and ability to engage in different and lifelong learning in the broadest context of technological change. PO12 is nothing but the lifelong learning. Here, the student will able to focus on what are the future aspects in his design or is in problem, whatever the problem is as taken in the definition of problem. Here, lifelong learning is nothing but what are the advancements will be there in the future design of these projects. Now we will try to see how program outcomes are assessed here. The PO1 engineering knowledge will be given the strength of 3, and it is evaluated by CIE, quiz and AIT. Similarly, PO2 is nothing but problem analysis, identify, formulate, revive literature research. All these concepts are undergoes a strength of 2, and they are evaluated by same CIE, quiz and AAT. Similarly, PO3 design and development of solutions, it has a strength of 1, and it is evaluated by same CIE, quiz and AAT. PO4 is nothing but conduct the investigation of complex problem, and it is given the strength of 1, and it is evaluated for CAE and quiz and AIT. The strengths given above are based upon the subject's level, how these outcomes are mapped. These 4 program outcomes are mapped for this particular engineering subject, and nothing but engineering tribology. You will be having the engineering knowledge, problem analysis, design development, and conduct the investigation of complex problems. Among the 12 program outcomes, 4 program outcomes are mapped to this particular subject with the strengths of whatever you can see in the screen. 3, 2, 1, 1. Now we will try to see what are program specific outcomes. Program specific outcomes are assessed. We will try to see what are the program specific outcomes of the mechanical engineering department. PSO1 is nothing but focus on ideation and research towards the digital manufacturing, product development using additive manufacturing, computer numerical simulation, and high speed machining. This is PSO1, and PSO2 is nothing but formulate, evaluate the concept of thermofluid system to provide solution for interdisciplinary engineering application. This particular subject, engineering tribology, mainly uses in manufacturing industries where conventional lathes are used, CNC lathes are used, and high speed machinings are used. In such cases, they will be using what are the ideas and the researches can be possible with this one, because engineering tribology is subject which deals with latest innovations in the industry. So PSO1 is uh, completely will have the strength of 3, and it is evaluated with the help of quiz. And PSO2, because in engineering tribology most of the surfaces undergo the friction, and the friction will undergo the heat generation. When the heat generation will be there, there is the thermal effect will be there. To remove that thermal effect, you will be have to use coolants or lubrication. In such cases, thermofluid systems will be developed in interdisciplinary engineering application. So here the strength for this particular PSO is 2, and it is evaluated by quiz. The mapping of the each of the CO with POs, you can see in the table over here. The course outcomes CO1 is mapped to PO1, PO3, PO6, and PO7 and PSO1. PSO1, and CO2 is mapped to PO1 and PO2, and PSO1. Similarly, CO3 is mapped to PO1, PO4 and the PSO2. Similarly, CO5 is mapped to what we will call PO1 and PO2, and CO6 is mapped to PO1 only. Now we will try to see the justification for CO, PO and PSO mapping, direct and indirect will be discussed later. Now we will try to see the justification for CO, POs. You can see the CO1, it is mapped to PO1, PO3, PO6, PO7 and PSO1. PO1 is nothing but develop the surface topology of different materials, properties and the measure interaction between applying the knowledge of maths, science and engineering development. It is key competencies are 3. And CO1 is also mapped to PO3, nothing but develop a relevant surface interaction for material to find the sliding friction, rolling friction and the other frictional properties that meet the specific needs of safety and the environmental condition. Here key competencies are 2, and the PO6 is also mapped to the CO1. Here extend the theory of friction for metal and non-metal materials by the contextual knowledge to access the safety and the consequent responsibility and relevant to professional engineering practice. Here key competencies are 1. Professional engineering practices. CO1 is also mapped to what we'll call PO7. Here understand the impact of surface interaction in metallic and non-metallic materials in extreme condition for engineering solutions and in environmental context for sustainability development. 2. PSO1 is nothing but ability to apply the principle of friction and surface topology for measuring of complex design, and key competencies are complex design, you can see here. Next, CO2 is not mapped to only 2 program outcomes, PO1 and the PSO1. CO2 is nothing but identify the different types of wears for different mechanism and using the knowledge of mathematics, science and the engineering fundamental for specialized application in the surface treatment. Here key competencies are 3: engineering fundamentals, knowledge of mathematics, science and the for the specified applications. And the PSO1 is nothing but the develop a resource to identify wear during the high speed measuring process during the international standards of friction and wear measurement, using international standards and wear measurement. Here the strength is nothing but 1. Course outcome 3 is subject are mapped with the PO1 and PO4. Here PO1 is nothing but make use of lubricating properties for different materials by applying the knowledge of mathematics and the science and engineering fundamentals for dynamic conditions of machining. And the PO4 is nothing but identify the research methods for boundary lubrication to design experiments, analyze and interpretation of the result to provide valid conclusion in dynamic lubrications. Here the key competencies are 3 and the key competencies are 4. You can see the knowledge of mathematical and the science and engineering fundamentals. Similarly, you can see here design experiment, analyze and interpretation results. And the CO3 also mapped for PSO1, identify suitable method for application of lubrication and during the high speed machining process, and the key competency is first one for the method of lubrication, suitable method. And the CO4 is mapped only for PO1, and here list out the different types of corrosions. Factors influence the corrosion during the selection of material by the applying the knowledge of engineering fundamentals 1. CO5 is mapped with PO1 and PO2. PO1 is nothing but Identify the factors influencing the corrosion of material by the knowledge of engineering fundamental. Your key competencies are nothing but the engineering fundamental, that is only one. And PO2 is nothing but the relate the various factors influencing the corrosion to identify, formulate complex engineering problems for production of different materials. Here, three competencies are there: identify, formulate, and complex engineering problems. And the CO6 is formulated with subjected to PO1, and that is nothing but a select material, and it allows the based on tribological application by applying the knowledge of science engineering fundamental for engineering material. Here, key competencies are two: engineering knowledge, applying the engineering knowledge, and the engineering fundamentals for engineering materials. These are how the key, program outcomes are justified with the help of COs and with the help of key competencies. Next one is total count of key competencies for CO and PO, PSO mappings. Here you can see the course outcomes, program outcomes, and the PSOs. Number of key competencies are there. For CO1 and related to PO1, it is key competencies are 3. CO1 PO3 is 2. CO1 PO6 is 1. CO1 PO7 is 2. Again, CO1 PSO1 is 1. Similarly, if you see the CO2, it is key competencies for PO1 is 3 and PSO1 is 1. Similarly, CO3 key competencies are 3 and PO4 it is 4 and the PSO1 is 1. Similarly, CO4 related to PO1 key competencies are 1 and CO5 key PO1 key competencies are 1 and PO2 key competencies are 3. And for CO6 PO1 key competencies are 2. Okay, coming to the next one, 14th one, percentage of key competencies for COPO and PSO. Here you can see here the percentages are given based upon the strength. You can see this one. If it is 3 is there, then it is between 100%. That's why we are kept 100 over here. Okay. And wherever the 3 was there in earlier one, we have kept 300%, 100%. So, and wherever it is 2, we have kept 60. And wherever it is 1 is there, then we have kept 40%. So here 3, 3, 3, wherever 3 is there. So it is means 100% means 3 and 60% means 2 and 40% means 1. Like that, based upon the previous table, key count number of key competencies, here percentages are kept here. Next, 15th one, course articulation matrix PO and PSO mapping based upon here number of key competencies 3, 3, 3, 3, 3, and total is 13. And total is 13 and divided by 6 terms, you will be getting 12 here, 2 here, and you can see here 3, 3 here, 9, 10, 11 and 12. 12 divided by 6 COs, you will be getting 2, average is 2, and for PSO 2, it is 3, 3 divided by 1, and you will be getting 1 only here, 3. Okay, like that. PSO 3 and PSO 3 you will be getting 2 and 2, here you will be getting 2, and PSO 4 divided by total 4 divided by 1, you will be getting 4. You can see PO 6 and 1 divided by 1, here 1 you will getting, and 2 here 2 divided by 2, and this one you will be getting, and here you can see PSO 1 3 divided by 3, you will getting 1 here. Course articulation matrix. Now see the assessment methodology direct, and we also having the assessment methodology indirect. Assessment methodology direct, you will be having CI exams, SE exams, seminars, and the 5 minutes video and the assignments. Whereas in indirect assessment is done by assessment of mini project by experts and the end semester OBE feedback. You can see the syllabus here. First module 1 is surface interaction and the friction. In this unit, students will be studying about the surface topology, surface features and the properties and measurements, surface interaction, adhesive theory of sliding friction, rolling friction, and the friction properties of metallic and non-metallic materials, and the friction in extreme conditions and thermal considerations in sliding contact. In the module 2, students will be studying about the wear and the surface treatment. In this unit, students will be studying about the types of wears, mechanism of wear, various types of wears, laws of wears, theoretical wear models, and the wear of metals and non-metals, and surface treatments and surface modification, surface coating methods, and international standards in the friction and the wear measurements. You can see in the module 3, students will be studying about the lubrications and the lubrication regimes. In this unit, students will study lubricants and their physical properties, viscosity and other properties of oil, additives and selection of lubrication, lubrication standard ISO, SAE and AGMA BO standards, and lubricant regimes such as solid lubrication, dry and marginally lubricated, contact boundary lubrication, hydrodynamic lubrication, elasto and plasto hydrodynamic lubrication, and electrostatic hydrostatic lubrication. In the fourth unit, the students will be studying about the corrosion. Here, the students will have the introduction to the corrosion and the principle of corrosion and classification of corrosion and the various types of corrosions, factors influencing the corrosion and testing methods of corrosion and the evaluation of corrosion, and how to prevent the corrosion, and material selection and alteration of environment, cathode and anodic protection. Okay, in the fifth unit, students will be studying about the engineering materials. Here, general introduction will be given to the students about all materials, and especially focused on the advanced alloys, super alloys, titanium alloys, magnesium alloys, aluminum alloys, and nickel-based alloys, ceramics, polymers, and its applications in the various industries. Now, let us discuss course plan, textbooks about this one. The generally followed textbooks for engineering tribology is by Butterworth and Heyman, published in 2018, and second one is Robin Wick's Friction and Wear of Material, and John Wilson publications. Reference books are Fundamentals of Tribology by Prentice Hill Hall of India Private Limited, authored by S.K. Basu. And the web references, you can see www.tribology.abc.com, and you can see mit.education also courses. And the course web page is nothing but you can see in our CMS or ALMS, the Akanksha by UG20 by /B Vijay Krishna. You can see in the material by Engineering Tribology by B Vijay Krishna. Now we will try to see the course plan for this one. The course plan is meant as a guideline. Probably there may be changes. Okay. In the first unit, in the first class, we will be discussing about the OBE of the engineering tribology subject. Nothing but the course description, COPO, what are COs, what are POs, and COPO mapping, and our course articulation matrix. In the second class onwards, you will be having the second topic is nothing but topography of surface. It is related to CO1, and the textbooks, you can see that textbook 1. And the third class, you will be having the surface interaction related to CO1, and the second textbook is followed. And the fourth one is adhesive theory of sliding friction related to CO2, and the first textbook is followed. Fifth class, we will be discussing about the friction properties of metallic and non-metallic, and the CO2 is related to CO2, and textbook 2 is followed. Sixth one is friction. Next topic is friction in condition related to CO2, and the next topic is thermal consideration in sliding contact related to CO2, and the textbook 2 is followed. Next topic is types of weights and the related to CO3, and the second textbook and the first textbook also referred. And the ninth topic is mechanism of various types. Here CO3 is related and the textbook 2 and 1 is followed. Here, next topic is theoretical wear models. After that, you can see continuously wear of metals and non-metals, surface treatment, surface notification, surface coating methods, and the international standard in friction and wear measurements. All these are related to CO3 and they are referred to the respective textbooks given in the PPT here. Next, the seventh class, lubricants and their physical properties, viscosity, additives and selection of lubricants, lubrication standards, and the lubrication regimes and solid lubrication, dry and marginal lubricated contacts, boundary lubrication, hydrodynamic lubrication, and elastoplasto lubrication. All these are related to CO4 and their respective textbooks are referred. From next onwards, you can see the principle of corrosion, classification of corrosion, types of corrosion, factors influencing testing of corrosion, and the evaluation corrosion, prevention of corrosion, and material selection. All these are related to CO5 and the CO6. CO5 material selection, and CO6 you can see alteration of environment, ceramics, polymers, and the application. All these topics are related to CO6 and the respective textbooks are followed here. And you can see the problem solving or the case studies here. Total 15 topics will be there, upon which you can have the problems or you can do the case study on that one. The first one is rolling friction. Second one, frictional properties of metallic and non-metallic. Third one, thermal consideration in sliding contact bearing. Fourth one, law of weights. Fifth one, wear of metals and non-metals. Sixth one, international standards in friction and wear measurement. Seventh one, viscosity and other properties of oils. Solid friction, solid lubrication, boundary lubrication, hydrodynamic lubrication, evaluation of corrosion, cathode and anodic protection, advanced alloys and super alloys, and the titanium alloys, magnesium alloys, and ceramics, polymers, and its application. These are the topics upon which you can be doing problems, and also you can do on the case studies. These are related to all 6 COs here, and the respective reference books can be followed here, which are quoted in this table. You can see the discussion of definition and terminology here. Surface interaction and friction first unit, you will be having the number of definition in this topic. So this topic will be related to CO1 and CO2. In the second unit, you will be having the wear and surface treatment. You can have the number of definitions in this one, and we will discuss in the classroom. It is related to CO3. And the lubrications and lubrication regimes, here you will be having the number of definitions in that one. It is related to CO4, and fourth one is corrosion, and the fifth one is engineering materials. All these topics will be having a number of definitions which will be discussed in respective classes, and these are related to respective COs, and you can refer the references books over there. Okay, next we will discuss about the discussion of question bank. Module 1 is surface interaction and friction. Module 2 is wear and surface treatment, and module 3 is lubrication and lubricating regimes, and the fourth one is corrosion, and fifth one engineering material. In the class, we will discussing about the important questions, and it will be provided with the question bank, which can be available in the LMS of a respective subject. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.